Hi guys, hi everyone. Quickly confirm me whether I'm audible or not. I want you to confirm quickly in the chat. If I'm audible, then we'll directly straight away get into the questions. Yeah, type in the chat. Yes, hi. So Nagendra is back. Parvesh, Jai Hind. Ramesh, Madhan. Okay, today we have very interesting questions. Let's see how many of you will answer correctly. Okay, really beautiful questions are there, very challenging, not interesting questions, not difficult questions. Okay, very simple questions, but you can answer only those questions once you know the concept. Okay, so not all questions, some questions are like that. I mean, from 25th question onwards, you will get those questions. Okay. So in the previous lecture, in the previous video, we discussed about what? We discussed about how many questions we discussed? Yeah? How many questions? Tell me. What is the question number we ended with in the previous discussion? Yeah. Question number 20. Question number 20 was done, right? Now it's time for question number 21. Okay? Yeah, 10 questions, but question number was 20. So 21st question. Okay, 21st question. Oops, let me just zoom it a bit. Yeah, timer is running already. Okay, the moment you get the question, timer will start automatically. Okay, everything is programmed in such a way that every question you will get 90 seconds. You have to answer and you should recollect the concepts. Don't be in a hurry. Try to be correct. Okay? Yeah. Always I say the same. Don't be in a hurry. Try to be accurate. Yeah. Oh, cool. Manikanta has answered already. According to him, the answer is D. Okay. Give it a thumbs up, guys. Give it a thumbs up. Share the video. We got some interesting questions today. Nagendra is saying D. Manikanta is saying D. You got 20 more seconds. Let's see how many of you will answer it. Sir, in distribution system, see why you are going for distribution system. We're talking about electrical circuits. Try to be here. Okay. Try to ask questions related to the topics what I discussed. Then I'll take you to general questions, general live sessions I'll take. There we'll talk about those. You got just 1 second. Boom, time's up. Let's see what is asked here. Let's see what is asked here. You got here for a true resonance in RC circuit, which of the following is true? Okay, which of the following is true at resonance in LC circuit? Okay, series impedance. See, generally, resonance means what? Resonance means, in case of, let's talk in terms of conditions. Okay, in case of a series resonance, series circuit resonance, or parallel circuit resonance, condition is XL equal to XC at this particular, for these two circuits only. In general, what is resonance means, don't say that XL is equal to XC, that's different. Okay, XL is equal to XC only for series as well as parallel circuits. What is resonance? The basic concepts, what's the core understanding of resonance, everything already discussed in 0 to hero course of network theory or electric circuits or network analysis, all the names are same. Okay, So there I discussed all these things. You can go to that. Now coming to this, in case of a series RLC circuit, let's quickly draw the series RLC circuit. Okay, I just drawn series RLC circuit where XL is equal to XZ. What is the impedance formula? Z is equal to R plus J XL minus XC. Okay, so the moment XL is equal to XC, so this term has become 0. So Z is equal to R, which is least possible value, which is minimum. Okay, in case of parallel RLC circuit, admittance will be minimum. Means impedance Z will be maximum for RLC parallel circuit. Okay, at resonance. Now if you just look into these options, what you got here, what is given? The series impedance of the two elements is at maximum and parallel impedance is at minimum. No, it's reverse. So this is wrong. The series impedance of two elements is at maximum and parallel impedance, one is minimum, another one is maximum. That is happening only in this case. The series impedance of two elements is at its minimum, parallel impedance is at its maximum. So answer D. Absolutely right, those who marked answer as D. Okay, very good, Nagendra. You have given beautiful explanation like every time you give. Okay, I'm moving to the next question. Yes, next question. Timer is running. Answer it quick. Give it a thumbs up. If you got correct, if you understand the concept, give it a thumbs up. I don't know what to say every time. Give it. Wow, Manikanta is saying B, full to entertainment. Wow, full to entertainment is saying 15.2 ohm, which is B. Madhav is saying B. Wow, we got a lot of people who are saying B. So B must be the right answer. Let's see what others had to say about it. Nagendra is also saying B. So hopefully B will be the right answer. Okay. Because Nagendra has been consistently giving right answers right from the first session itself. Yeah. What is the resistance of coil which draws 10 ampere and dissipates 15-20 watt? It's simple. We know power is equal to I square into R. Right? So power value is given as 1520. I square value is 100 because I is 10, I square is 100. So simply it is B. It is just maybe 15 seconds question. That's why people answered very quickly. Okay, very good. You can also go for V square by R formula. You can also go for V into I formula. This is for power, average power to be more precise. In case of DC circuits, in case of AC circuits, we'll go for VA cos phi. Power factor also comes into place. Okay, so but average power in terms of current, if you want to talk in terms of AC also, it is same, I square into R, but not this. This won't come in case of AC. Okay. Anyways, I'll move to the next question. Are you guys ready? For 3-phase I square, for 3-phase, 3 times of I square R phase value per phase current will take for 3-phase circuits. Okay. So yeah, √3 VI cos phi. Okay, line current, line voltages. If it is a phase, 3 times of V phase into I phase into cos phi. That's absolutely true. I'm into the next question. Do you understood this? Now we're coming close to some of the interesting questions. We're coming close. Just there are 2 questions far away from the interesting questions. Yes, Nagendra, you're right. Yes, good. Keep it up. Simple question. Very simple question. I think if you don't have the calculator handy, you can just guess with approximate numbers. Okay, you try to guess with approximate numbers if you don't have a calculator. Okay. Yes, you're right. Manikanta is answered already. And free tests are available in the app. Free test. Okay, you can just download the app. You can start giving your free tests. Okay, so that you will know how nicely you're doing. Okay, based on subject-wise test, mock tests are given. Just go to the app. You will get all those details. Okay. Nagendra is saying B. Okay. Yeah, Nagendra, give it a check. Prem is also saying B. Madhav is saying A, as well as Manikanta is saying A. We just got 10 seconds left. Time's up. Not 10 seconds. Time's up already. So, what is the question? What is the RMS value of or RMS voltage in a series RC circuit if the voltage across R and L is 256 and 192 volts? So the formula is, if you just have R and L and this voltage is 256 and this voltage is 192, then what is the resultant voltage? That's what is asked. Okay, V in is equal to square root of 256 square plus 192 square. Okay, 256 square plus 192 square. 192 square. Okay, so just do this, you will get A as answer. You will get A as answer. You will get A as answer. Okay, resultant. Because if you just draw quickly the vector diagram for this, how you know this is a formula? If you just draw the vector diagram, voltage across the resistor is over here and voltage across the inductor will be over here. So resultant will be this. This is the resultant resultant voltage. Okay, so by using this formula we'll get it this. It's simple. It's simple. Yes, inductor is lagging, inductor in case of capacitor is leading. Now you want to know why inductor will be lagging and why capacitor will be leading and what is this leading lagging concept. Are you facing any trouble in drawing the phasor diagrams? You just download the app. There the free content is available and it will explain all these things about leading, lagging, how to draw the phasor diagram. Everything will be clearly explained there for free. Just enjoy those free videos. I'm moving to the next question. Okay, I'm moving to the next question now. Yeah, next question is here. Answer it. Haldar is saying yeah. Okay, only Nagendra used to explain nicely. Others, they don't want to participate, just giving answer and then just leaving. B, we got full 2 entertainment is saying as B. Sunil Kumar is saying B. Nagendra is saying A. Sampath Kumar is saying B. Okay, Vinay is saying C. We got mixed answers. Let's see, that's gonna be interesting then. Because of V is equal to I into R, he explained about something, Nagendra, and he's saying A to that. Okay, let's check it. Let's check for other answers. Let's wait and watch. Let's wait and watch. Read the question carefully. You don't have to be in a hurry. Come on, you don't have to be in a hurry. Yeah, if you're having any question, just draw the circuit simply. Draw the circuit. What is saying? A circuit with 4 resistors are connected in series to the voltage source. Now what happens to the voltage across each resistor if each of the resistance is doubled? If each of the resistance is doubled, then what will happen to the voltage across each resistor? Just quickly draw a circuit. Quickly draw a circuit. So now the resultant, each resistance value has doubled means what? Equivalent series connected equivalent resistance also become double 2 times of R. For the same voltage, resistance has become 2 times, so current will become half of the earlier current. Second case, current will be half of first case. Now it is asked for voltage across each resistor voltage. That will be product of this and this, 2 to get cancelled, which will be same as before. Answer is B. Nagendra, what happened to you? D? My God, 0. Are you clear now? Are you clear now, guys? Give it a thumbs up. If you are clear, give it a thumbs up. If you want to explain a little more details, tell me, I'll explain. Yes, Sampath, you're absolutely right. Yeah, I think it seems you have no questions on this. I'm moving to the next question. Are you having any queries on this? It's simple. Answer is B. Okay. Yeah, good. Praveen is given a clear chit. So I'm moving to the next question. This is an easy piece. Come on. I want you to quickly answer. Just like that. Within 10 seconds, you have to answer this. Next question onwards, something interesting is going to come up. Yeah, confusion. You should be careful. Just, nothing to worry. Go back to the rebroadcast and watch it again after the session. You will understand, Nagendra. It's simple concept. You go back and watch it, you will understand. There is nothing difficult here. You just missed it. You're smart enough to understand. It's just lack of attention. You need to keep that attention. Wow, good. The network that consists of at least a voltage source or a current source is called as an active network. If network is not having any active source, any voltage source or current source, it is a passive network. If you have, these are voltage sources, means here in this case I am considering them as independent voltage sources. If the network is just having dependent sources, no independent sources, then also it is a passive or dead network, you will say. What is the network? Dead network. Okay. So for the network to say it as an active network, it should have at least one independent voltage source or one independent current source. Clear? I'm moving to the next question. Generator, battery, all these things, good. And a lot of people will ask, sir, can you tell me what is the example of ideal or maybe current source? Forget about ideal sources will not have that. Just for the sake of characteristics, we'll talk about ideal feature. Can you name a current source? In case of voltage source, battery, generator, X, Y, all these things. Can you name current source examples? Yes, I want to see your answers. What is a current source example? If somebody asks in an interview, can you name one current source which what you will say? Yes, absolutely, full to entertainment. Solar panel can work as constant or current source. It can also work as a voltage source. Okay. And there are analog circuits, current mirrors. You can make them work as current source. Okay. Yes, you're absolutely right. It's absolutely right. Okay, I'm moving to the next question. Let's see. This is a simple question. You may think, it may seems to be a little bigger question, but it is actually a simple question. Okay. Don't just go panic by looking at the size of the question. Okay. So yeah, it's gonna be easy one. Give it a thumbs up if you know the current source example right now. I want you to thumbs up. We got 40 seconds left. It's an easy one, not even difficult. It's an interesting one. Yeah. There is a trap. There is a trap. There is a trap. Be careful when you're answering. There is a trap. There is a trap. There is a trap, I'm saying. There is a trap. All of you got trapped. All of you, the one who has answered, got trapped in the question. In the trap which is given, except Sampath. Except Sampath, everybody is trapped. Answer is A, because Sampath's answer is absolutely true. Praveen is also true. But what happened to everybody else? Just they're looking at this plus pi by 4. So 10 root 2, it is a maximum value. When you are representing a phasor quantity, we'll talk in terms of RMS value. That's why you might be thinking 10. You're taking just 10 root 2 by root 2, which is RMS value of this maximum value. At an angle, this is 45 degrees. So you might be taking this is plus pi by 4. You might be taking like that. That is wrong. Why it is wrong? It is wrong because this is a cosine. This is a sine. When you want to compare two vectors, two phasors, what you need to do? You have to bring them into either sine or cosine. You need to bring them either into sine or cosine. Okay, so which you have not done, that's why it's gone wrong. Okay, yeah. Now, at least now try to bring what we'll do. Generally, sine will be having, let me take sine over here. Sine reference is here. This is plus sine. Minus a sine will be here. Can you tell me where will be plus cosine? Plus cosine will be, yes, upward is plus cosine, and this is minus cosine compared to plus sine. This will be, cosine will be leading to this sine by 90 degrees. Now, this is a voltage which is given as cosine, no angle delay. So this is a voltage vector is along this. Now the current vector is along sine with a plus pi by 4 plus 45 degrees. This is the current vector which is 45 degrees. Now tell me what is this? This is also 45 degrees. Now with respect to the voltage, current is leading or lagging? Tell me. Current is leading or lagging? Tell me. Yes, current is leading or lagging? It is lagging. I told you, you have to watch that phasor diagram video, okay, which is given on YouTube also. It is given on the app also, everywhere, and the beautiful concept is given for leading and lagging with interesting animations. You will fall in love with phasor diagram, believe me. And once you love it, you comment me. Then I'll understand, okay, you loved it. You share with your friends. Yes, it is lagging. Means minus pi by 4 with respect to the voltage. Okay. Clear? Great. So answer is A. I'll move to the next question. Okay. Shall I move to the next question? Give it a thumbs up. I'll move to the next question. Great. This is an easy one. If you're smart enough, you can quickly and easily answer this question. Good. Timer is running. Answer. Quick. You should be quick enough in answering it. Nice. That's good. That's really good. P is equal to average power delivered. It is asked for what? It is asked for average power delivered. Average power delivered means what? It is P, simply capital P, active power. Active power is equal to, just now I discussed, active power is equal to P is equal to IRMS square into resistance. Resistance value is 4 ohms. I'll only take a resistance 4 ohm. RMS current is 5 is a maximum value. RMS value will be 5 by root 2 whole square into 4. Okay, so just solve is 25 by 2 into 4, which is 50 watt. That is it. How simple is this? How simple is this? But very interesting. Okay, we're just 3 questions away to end the session, and they're interesting questions. Yes. You do it. You do this one. This is 1 ohm. This is interesting. Let's see. Yeah, you're absolutely right, Nagendra. Nagendra is nicely giving explanations also. I am also giving, Nagendra is also giving. Others, you can also give. That's how you'll be training your mind. Okay. Yes. Do it quick. You don't have to use calculator for this. Come on, no calculator is required. Simply you can answer this if you understand the basic understanding of networks or circuits, you can call. You don't have to go for calculator. You don't require calculator. No, Nagendra. PDC minus PAC. What is this PDC minus PAC? Madhav has said D. Without using calculator, Madhav has said D. It is PiSquare control system. Okay, so you must be enjoying the control system then, PiSquare control system, because we designed the control systems in a beautiful way so that when I am saying it's a PiSquare control system, it's great. Good to hear this name, because we have given you a control system in a new dimension which you might have never experienced. Go to the free lectures, download the app and watch the free lectures. Okay, coming to this question. What is this? It is a current, DC current as well as some AC component of the current is given. What is the resultant current? Resultant current will be square root of this DC component square, 2 square plus this RMS value. RMS value is how much? 6 by root 2 whole square. This is RMS value. This is average value of this. Now you find out this. What is this? 4 plus 36 by 2, which is 18, which is equal to root 22. Now what is said? Power dissipated in the resistor of 1 ohm. We know P is equal to I square into R. P is equal to I square into R. 22 under root square is 22 itself. Into 1 is 22. Are you using calculator? No. No calculator. Directly done. Okay. Shall we move to the next question? Yes, let's move to the next question. Oh. You try this better. You try to do this and give in the comment. Let's see how many of you will do that as an exercise for you. You might be thinking it is something difficult. No, if you understand the basic ideology of the maximum power transfer theorem, where load resistance must be equal to the source resistance. If you understand that to its core level, then you will answer. I'll give a hint here. I'll give a small hint here so that you will be able to answer in the comment. Okay. So here, if you have, I'm taking a DC circuit. For a maximum, under maximum power transfer condition, if this is R, this is RL, these two must be having equal R. L must be equal to R for the maximum power transfer to happen. Under such cases, if this voltage is V, this voltage will be V by 2, this voltage will be V by 2, both the voltage will be half. Okay, use this concept and try to answer this question and give in the comment section. Okay, try doing this, take your time, do this, but definitely must answer. Okay, I'm moving to the next question. Answer you will get it as, no, you answer it, I'll pin that answer in the comment. Okay, yeah, I'm moving to the next one. Boom. Yes, this is also an easy one. I think can answer it, but a tricky one. This is the last question of the session. You have to be quick in answering this. It's simple. It's just a conceptual question. Are you doing it? Come on. Timer is running. It's simple, right? Get ready with your scribble pad, rough pad, so that you can quickly do some math, the basic functions. You can do that. Otherwise, just, is it a movie you're just watching like that? No, it doesn't make any sense, right? It's a PYQ session. You need to revise the concepts what you learned. You need to put it on a paper. Do that. I am for magnetizing current. No, not magnetizing current. It's a maximum current, dear. Come on. It's a maximum current. Yeah, time's up. Now it's my turn to answer this question. Because time's up. Let me answer this. Last question of this session. Okay. The current drawn from two-phase load is this as well as this. Okay, so two-phase loads, current is this. Now these two currents will be balanced. Tell me, for two-phase, balance means what? Balance means what? For a two-phase condition, tell me for three-phase. Three-phase balanced, three-phase currents are balanced means what? Tell me. Yes, I want to hear from you. Three-phase currents are balanced means what? Yeah. I'm listening. I'm looking at the screen. I mean, I'm not listening. Balanced means, three-phase case, balanced means all three-phase currents are having same magnitude and they are displaced by 120 degrees. They are displaced by 120 degrees to each other. That is what three-phase balanced means. Now, in case of two-phase, yes, everybody is right. In case of a two-phase, tell me what is a balance condition means. Only you have two phases. What is a balance condition? Yes, for two-phase, I1 and I2, they must be having 90 degrees displaced. So if this is 0 degree, this must be minus 90 degrees. It is lagging. Okay, so basically it is 90 degrees displaced to each other. That's what two-phase balance means. Now, if this is, suppose let me take it as 0 degrees, then this should be how much? Theta 2 should be 90. If this is a 10 degrees, this should be 100 degrees. Simple. So, theta 1 and theta 2 must be having 90 degrees displacement. Let's see, theta 1 is, theta 2 no. If theta 1, theta 2 are same, they are in phase. So this is wrong. If theta 1 is minus theta 2, they are out of phase, 180 degrees. So this is wrong. Theta 1 is 5 by 2, but I want theta 2, where is theta 2? That's the relation we want, right? So theta 1 is equal to pi by 2 plus theta 2. Okay, so that you will know theta 1 minus theta 2 will be 90 degrees. Okay, this will be the answer for this. So answer is B. Answer is B for this. Not 90 degrees. Okay, the angle will be 90 degrees for two phase. That's what you're trying to say, I think. So that is it. That is it. So we have seen some questions based on this KPTCL AE electrical questions, previous year questions from electric circuits. Okay. So in the next session, I'll come up with some other subject. Maybe power electronics, maybe measurements, maybe control system, as when I is saying PiSquare style control systems. I'll try to bring those PYQs in the next session. Okay, and meanwhile you have to answer this. You have to answer this question in the comment. Okay, try doing it. Take a screenshot and do it and give it in the comment. That's it. That's the end of today's session. Okay, now Sampathi is asking a question. Sir, in distribution system, all the mains are connected in parallel. So the healthy section current enter in phase, leave the neutral. So now other mains neutral is, what other main neutral? Distribution system, other main neutral, everything is same, right? Okay, he is having continuation to that. The healthy section neutral current is grounded through fault. Neutral wire, sir, maybe that's why AC neutral link is okay. In case of neutral link, okay, I think he's talking about our video, PiSquare video. Okay, why in case of phase we use a fuse, in case of a neutral we use a link. Okay, so he's trying to answer to that question, because in case of a three-phase system, his point is when you have a three-phase system, so three phases are there. Now if one phase healthy section is broken, neutral should not break, because our Y phase, B phase has to take the return current through this B phase, as well as Y phase return currents has to go through this neutral. Okay, so in case of a three-phase system, one phase is broken, even then neutral should not break, because other phase current has to allowed, currents has to be allowed. So that's why in case of a three-phase system, you are having a neutral link is placed in place of fuse. You are placing a link in three-phase system, because that's fine, it is making sense. But why in case of a single-phase system? In case of a single-phase system, yes, it should not be broken. All these details are explained already. Yes, you're Sampath, you're absolutely right. Two fuse, this is related to two fuse. Two fuses, I already said. Why in case of a DC, both the positive terminal as well as negative terminal, we're having a fuse in case of positive and negative in case of a DC means? Here DC negative is not necessarily this is 0 volts. This might have this potential difference is 230 volts. This may be 0 volt, this may be minus 230 volts. Okay, that is also possible. This may be like US system, this may be plus 115 volt, this is minus 115 volt. That is also possible. So both the difference is basically 230. That's what the main thing here. Okay, so in that case, this also has its own path. This will also have its own path. Okay, anyways, I think you just rewatch that video once again, you will understand more clarity. I think you're already having a better clarity. Okay, you will get more clarity after this. Apart from that, if you have any other question, you can just contact us. That's it. That's the end of this question. You guys go to our Y series question. In Y series question, in Y series playlist, in the description of this video, different playlists are available. You just go through those playlists. You will get some interview questions also. Okay, anyways, let me end this session here. That's it. That's it. I was messaging in your PiSquare, sir, with this screenshot. Okay, we'll see that. Okay guys, catch you up in the next session. Have a good time, happy learning, and enjoy the learning in PiSquare style. See you in the next session.